Hey, fellow problem solvers, Colfax Math here. Today we have a calculus problem or a calculus idea looking at maximum and minimums, global and local, stationary points, and an example problem. So with the maximum and minimum, you could have a maximum right here, but not the absolute maximum. And this is called a local max. This would be a min, a low point in the graph. So this would be a local minimum. And then this value up here could be a local maximum, but it could also be the global maximum if it is the highest maximum in the whole thing. To figure out a max or a min, there are actually two criteria. The first criteria is you need to find the derivative and set it equal to 0. Remember, the derivative is the slope of a line. So that slope is the slope of this pen here. You could see it's positive. And then right at that max, it becomes 0. And then it becomes negative, becomes 0. So one of the two criteria is you find the derivative, set it equal to 0. But there's also a second criteria to figure out if it's a max or min. And this is an important one to note right here. The slope has to change signs. So right here again, that slope is positive. I get to 0, and then the slope is negative. So the slope changes signs on either side of the derivative equaling 0. And here's a case where you could actually have a derivative equal to 0, right? Somewhere in this graph right here, the derivative would be equal to 0, and it would not be a max or a min. It would really be what's called a stationary point or a point of inflection. So here your slope is positive, 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 0, and then it's positive and positive again. So even though the slope right here of the derivative is equal to 0, it is not a max or min because it does not meet both criteria, that the derivative is equal to 0 and that the slope has to change signs. So what we're going to do today is we're going to look at a sign chart. So let's look at our example problem. And then we're going to create a sign diagram to see if it is a max or min. Find the coordinates of the max or min point given this function. Well, let's start with right here. I could look at this thing graphically and see that it's a parabola opening down, but I'm going to run through all the algebra here. And there'd be a lot of ways to find that vertex from algebra 2. But the point here is to learn all of it algebraically so we could do harder and harder problems. Okay, so let me first find the derivative of this function, f prime, is going to be equal to, that 2 comes down in front, 2 times negative 2 is negative 4x, subtract 1, x to the first. 8x to the first, 1 comes down in front, 8, subtract 1, x to the 0 is equal to 1. And that constant drops off. So now I have my derivative of my function. I'm going to take that derivative and set it equal to 0. Negative 4x plus 8 is equal to 0. I'm going to subtract 8 from both sides. Negative 4x equals negative 8. Divide both sides by negative 4, and x is equal to 2. I want a coordinate, right, which is an x and y value. So I need to find the matching y value for that. So I'm going to take that 2 and plug it in here to find my corresponding y value. So when x is equal to 2, y is equal to negative 2, 2 squared plus 8 times 2 plus 6. 2 squared exponents first, 4. 4 times negative 2 is negative 8. Negative 8 and 6, negative 8 and 6, negative 2. Negative 2 and 16 is 14. So I have the coordinate now, x, y, and I think it's the vertex. I think it's going to be the maximum, but I'm going to double check that with a sign diagram. So when x is equal to 2, my derivative is equal to 0. And now, remember there are two conditions. One is I set the derivative equal to 0 and I solve. And then the sign, the slope of the derivative has to be different on the way up to the max and on the way down from the max. So when x is equal to 2, my slope is 0. I'm going to just pick 2 points on either side of that 2. Let's say a 1 and a 3. I'm going to take that 1, plug it into my derivative. So right here, I'm going to take that 1 and plug it in here to get negative 4 times 1 plus 8. I don't actually care what the number is. I just want to know positive or negative. Negative 4 plus 8 is equal to 4. It is a positive slope. And then on the 3 side, I'm going to do the same thing. I'm going to plug 3 in there. Negative 4 times 3 plus 8. Negative 12 plus 8, negative 4. It's a negative slope. So it meets 2 criteria. The vertex, the maximum, is equal to 214. It's a coordinate. And then the slope to the left of that value is positive, right, leaning this way, going uphill. And the slope to the right of it is negative. So remember, we have 2 criteria for our max. The derivative is equal to 0, and the slope has to change signs. So we have both of that. Our solution is 214, and we checked it with a sign diagram. Let's take a look at what that graph looks like. So here we are in Desmos, right? So here's our graph. And kind of what this whole thing is really about here is this is our function, right? Y equals negative 2x plus 8x plus 6. And I'm talking about the slope of this function. So the slope of this function is positive. Think of it as walking up a hill. Getting to the top, the maximum, slope is equal to 0. And then the slope is negative. We set the slope equal to 0 to find that x value, which was 2. We took that, plugged it back into our original function to find the y value of 14. So that vertex is 214. And then we set up our sign diagram to see that the slope at 1 was positive, and then the slope at 3 was negative. So we found the vertex, the maximum, using the derivative equal to 0, and then we just verified that it was not a stationary point like that in fact it was a maximum because of the sign change and the derivative equal to 0. Okay, thank you.